Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the construct string from binary tree problem. Yet another tree problem. We're on a surge of those at the moment. Given the root of a binary tree, construct a string consisting of parentheses and integers from a binary tree with the pre-ordered traversal way and return it. Not sure the grammar's quite right on that one, but I kind of get the gist. Omit all the empty parentheses pairs that do not affect the one-to-one mapping relationship between the string and the original binary tree. So for example, 1, 2, 3, 4. So this tree here, it's going to be a 1, then the 2 and the 4 are something, and the 3 is something, so they all need parentheses around them. You could arguably not need that either, but close enough. On this side, we need the 2 and we need the 4. There, you would need parentheses, but we don't need parentheses here. It's an empty child. We can kind of implicitly see that. The 3 obviously doesn't need children. So we're done and pass us back up here. Similarly down here, we want the 1, open parentheses 2. We're going to need empty parentheses there because otherwise the 4 would look like it's on this side, which is not what we want. So we include those empty parentheses. Right, so if I'm doing this problem, basically what I'm saying is I want to do stir of root hang on. If root equal is none, return none. Then what I want to do is L equals self dot tree to stir of root dot left. R is self dot tree to stir of root dot right. If L is none, let me get this out of the way. If the left is none, and R is none, L is an empty string, R is an empty string. So if both children are none, we're not going to be adding anything onto them. If L is none and R is not none, L is a pair of parentheses because we need it as a placeholder. Otherwise, R is open parentheses plus R plus close parentheses. So we're going to wrap R in parentheses because it's not none. We need to do that. So this 3 needed to be wrapped in parentheses. Else L is the parentheses wrapped around L. Probably using F strings for this, but I don't know if this version of Python is new enough. R is the same as before. Oops. And then finally, I'm going to do L plus R. So if this is the 1, it's not none, so I'm going to get all of the children here. I'm going to get all of the children here. Neither of them are none, so I'm going to wrap them both in parentheses and glue them all together. On this side, though, 2, this side was not none, and this side, oh, I need another check here, don't I? So if L is not none and R is none, L is the parentheses around the L, and the R stays the same. R stays as an empty thing, empty string. Oh no, R becomes an empty string. You probably just make sure this returns an empty string here. Anyway, this is fine. So we go down here. 4 is not none, but this side is, this none is none. So we're going to be in this case. So we're going to wrap parentheses around this 4 and just leave this side empty. This 4 has no children, so it's just going to become a 4. Yeah, that seems to work. Let's run this code. Ooh, actually, what are my size constraints here? Number of nodes in the tree is in a particular range. Ooh. Oh, root dot val. Blech. There we go. This could be slightly problematic in Python. If we've got 1,000 nodes. No, that's 10,000 nodes. We have 10,000 nodes and it's all down one side. Python might fail on this because my recursion will be too deep. Yeah, what do I do? Well, first off, let's use all the example test cases. Just make sure we're passing those. I'm fairly sure we are. Ah, heck, let's submit it. It's an easy problem. They're hopefully not going to give us any of these too awful edge cases. They did not. So my worry there was effectively if I had 10,000 nodes and they're all left, for example, that would cause us to recurse down 10,000 times. Python has a built-in limit of just under 1,000, so that would fail. I gambled. I won the gamble. There we go. Anyway, thank you very much for watching. Remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.